Okay, well, welcome to our talk on understanding intent in analytical conversations. Is everybody ready to hear the R&D behind the Ask Data feature?
Yeah.
Awesome. So I'm Melanie Tory. I've been at Tableau for about 3.5 years. I'm a researcher there, responsible for the user research we've been doing around Ask Data. My academic background is in visualization and human-computer interaction. I have a PhD from Simon Fraser University, and I've been working on Ask Data for some time now.
Hi, I'm Vidya Setlur. I just did like a 1.5 mile sprint from another part of the conference to here, so literally trying to catch my breath, but thank you for coming. I've been at Tableau for almost 6 years now. Have a background in natural language processing, graphics, and data visualization. PhD from Northwestern, Go Wildcats, if anybody's from that school. Yeah. So delighted to be here, and thank you for coming, even though it's lunchtime, so really appreciate it.
Okay, so hopefully you saw Ask Data at the keynote. How many people saw it? You can also check it out in the demo stations in Tableau Labs. I'm really excited about Ask Data because it allows you a different way of interacting with your data, a way that allows you to just ask the questions you have in the way you think about them. So if I had a data set about disease outbreaks, for example, I might just want to know which countries have whooping cough cases. I could just ask that question and straight away get a map like this that gives me my answer. And so this talk is going to give us a little bit of a behind-the-scenes look into the R&D that went into Ask Data, how we built it, what we needed to do to get to where we are today. We hope that having that little peekaboo in the back end will give you a better sense of how it works and help you and your organizations be more successful with it. And since this is in the research and innovation track, we are also just going to geek out a little bit around natural language processing and understanding intent in the way people ask questions, because that's just kind of cool. So the goals of today, first, I'd like to introduce the idea of what I mean by intent in an analytical conversation, and then spend some time talking about how we at Tableau have been learning about how people express intent and how our systems should respond. And then Vidya's going to come up about halfway through and talk about how we've been using that knowledge to build the product that you see today. So Tableau's all about helping people see and understand their data and interact with it in a myriad of ways. And we like to think of this as a sort of cycle of visual analysis, where you're not just asking a question and getting an answer. You're getting some data, asking a question, finding some insight, and that's going to inspire you to want to learn something else. So it keeps going. And of course, it's not totally linear. It's more like a back and forth between you and your data. And in this sense, interacting with your data is kind of like having a conversation with it. So this is what I mean when I say an analytical conversation, going back and forth between you and your data. And in research for the past few years, we've been thinking about how we could provide alternative modalities to make this process easier or just give you more options. And one of the things that we think about when we think of conversations is, of course, how we have conversations with other people. This is a really natural process. When we talk to another person, we don't have to think deeply about how to say the thing we're thinking about. It just comes out. We're so fluent in our languages that we don't have to think deeply about it, unless you're speaking another language, of course. So what we've been thinking about is how we can harness that intuition and bring it into analytical conversations to give you new ways of interacting with your data. So how can we bring that naturalness of a human conversation into conversations with data? Now, part of the challenge of enabling this is understanding something I'm going to call intent. As a dog owner, I love this cartoon. It illustrates how when we communicate with others, we have to convey our goals, and how sometimes that's not always easy. Even when we're communicating with another person, or in this case, a dog, it's not always obvious what people actually mean by what they're doing and saying. And this can be even harder for a computer-human conversation. Imagine a computer trying to understand you. All a computer has is the words you say, or the words you type. It's missing all of the nonverbal cues, like this dog is giving, and also people tend to really leave a lot of stuff out. They underspecify things, and we as humans are pretty good at filling in the gaps, guessing at, given the situation we're in, what somebody probably means. For a computer, that's really hard. We'll come back to that later. So intent, then, is understanding the analytical needs behind users' input utterances in an analytical conversation like this. And it's really challenging for a computer to guess at intent and do the right thing. And part of what I'll describe here is why that's the case. So a year ago, we knew that understanding intent in how people would express what they wanted was going to be super important. But we didn't know any more than that. We didn't know what intent meant. We didn't know how people would express it. So how can we learn that? And so last year at TC17, we actually ran a study at the Tableau labs downstairs to try and find out. How many of you have been to Tableau labs? If you haven't been, go check it out. There's a demo of Ask Data. We've got some studies going on. It's a place where we like to learn from you about your use cases and your needs so we can make the product better. And so last year at TC, we ran a study around understanding intent. And we wanted to know what kind of intents do people express when they interact with data, and what should the system do in response to those? Like, what were people expecting? Now, as a dev team, we had a challenge because we didn't understand anything about intent, so we hadn't built a product that would understand it. So how were we going to test that with people? We're kind of a little stumped. So we took an approach that is called a Wizard of Oz protocol. It's a type of method we use to allow people to interact with a system that doesn't exist. So how many of you have seen the movie Wizard of Oz? OK, great. So what I hope you remember from the movie is that there's this kind of big, powerful wizard who rules over the land, grants people wishes and things, and most people are scared of him because he's the all-powerful being. But at the end of the movie, you find out that this was all kind of a ruse, that actually he's just a normal person hiding behind a curtain, and he's got some machinery to make himself sound big and loud. So it's kind of faked. So that's what we did last year. We simulated or faked this system. People who came into our study might have thought they were interacting with a real system, but in fact, we had a wizard behind the scenes who was actually building visualizations for them. So this is a little video that illustrates what it would have been like to participate in our study. People were interacting with a data set about Titanic passengers. They would ask a question. The wizard would hide the screen from them, build a viz, then reveal it back. And then the participant could ask a follow-up question. The wizard would go build the viz for that, reveal it back. So it sort of simulated the way you would interact with a real system, but without us having had to build it first or understand how we should build it. And of course, you could interact with the charts that came up in all the normal way. So if anyone was in our study last year, thank you. It was actually super helpful to us, and I'll explain why. So we then took all of the data we gathered from those simulated interactions, and we used it to try to understand and build a model of what intent is. And what we realized was that the intents people expressed could be classified according to all of the major parts of a viz. So if you think about building a viz, you've got to put some data attributes in there. You might need to do some transformations like binning or writing a calc, so it's something that's not the original data. You might need to apply some filters, and then you're eventually going to put things onto shelves like color or rows or columns to visually encode your data into a chart type. And so people expressed intents around all of those 4 main parts of viz. And they also expressed intents moving from one state to the next and the next and the next in their conversation of how all of those 4 things should adapt as we move forward. Now, part of what we analyzed to get to that conclusion was looking at all of the places where the, quote, system did something that the participant said was really unexpected. Like, no, I didn't mean that. I wanted to see this other thing. Those instances were really helpful to us. And those broke down into all of these parts that you see. You can see that most often it was differences in the sort of visual encoding or chart type that were unexpected. Maybe you thought you were going to get a scatter plot. You got a bar chart instead. But there were also unexpected behaviors around all of the other aspects of a viz. So let's look at some examples that illustrate how people expressed intent in their input, how we learned that the system should respond to those, and what can go wrong if the system gets it wrong, doesn't understand intent right. So these are going to be real examples from our study from last year. Imagine that you've typed, "Show me children aboard who survived." So remember this data set of Titanic, and participants were supposed to be trying to figure out what were the kind of demographic attributes of the people that determined whether or not they survived the disaster. So if you ask that question, you might get a suitable viz like this with attributes children aboard, yes or no, survived, yes or no, and account. And the cues here in the input question that illustrate what the person actually wants are just straight up attribute names like children aboard. So then you might follow that up by saying, break this down by sex and age. And a suitable response here might be to take that bar chart and add sex and age as new attributes, but kind of preserve that bar chart structure that you had before. And in this case, there's another keyword, the word this, that indicates that the user really wants to keep what they had before and do something new to it, because that's a reference to the prior thing that they said. And then if you ask the question, what was the correlation between age, fair, and survival, it might be appropriate to give a heat map like this, or maybe a scatter plot, something that reveals a correlation. And in this case, this is a brand new question, and it's got pretty much completely new attributes in it, unrelated to what was there before. So this should be a cue to the system to say, no, this is not an addition to what we had. Just get rid of that. Give me something completely new. So these are cues that we were learning from our study that we could then implement in our system to have it do the right thing. Now, many, many things can go wrong with this. Let's look at an example. If you asked who survived, an appropriate response might be survived, yes and no, and account. And then in our study, a participant followed that up by asking what class were people in. And they got this viz with 3 different classes, cabin classes, 1, 2, and 3, and account. And this participant was actually quite annoyed at this response because to them, their question was a follow-up to the prior one. They wanted to keep whether or not people survived and add on the class information, and instead, we got rid of it and gave them something new. That was annoying. So that's what can go wrong when we don't get intent right. Let's look at another example, this one around the chart type. Let's say you've asked distribution of survivors by fare. So in that case, a heat map of the different fare buckets, the amount people paid, might be appropriate. Split this data by survived status. Might make sense to split that into 2 charts. One for survived is yes, one for no. And then scatter plot of survival status by age and fare now needs to be in a scatter plot form with those variables. And there's, again, a bunch of cues here that indicate what kind of chart people might expect to see. In the first case, the user has expressed an analytical goal. They want to see the distribution of the data. And we know from visual best practices that a good way to visualize a distribution is through a histogram. So that tells us what kind of chart to produce. In the second case, the user has expressed an explicit kind of visual encoding. They've said split this, which suggests taking something and breaking it apart into a sort of small multiple view. People would also say things like color by survive status, or size by fair, or things like this. And in the third case, they've explicitly named a chart type, in this case, a scatter plot. And things could go wrong in the visual encodings as well. Let's take the example, percent survived by each age bin. So this is a sort of histogram request. You want to see all the ages of the people on board, what percent of those survived. And then the person who asked this question wanted to take it one step further and just add on the count of how many were in each bin, because these 80-plus people survived at a 100% rate, but how many people is that really? So that's what they wanted to know. And so they asked a follow-up, percent survived for each age bin, so what I had before, plus the number. And if you think about a naive system that maybe just relied on show me, for example, we could just take all the named attributes, throw them into show me, and generate a chart. And this is the chart you get when you do that. This turns out to be a really bad chart for this task because it's taken age off the y-axis and moved it to color, which makes it very poor for understanding a distribution of the age. Plus, it's made a jarring change from one state to the next, where suddenly I don't necessarily know where age went. It feels to me like it might have disappeared. So hopefully, we should be able to do better than this in our system. So those were some of the cues that people expressed, the ways that they expressed what they actually intended to see. And we learned a bunch more of these in addition to the examples I gave you. Things also about filters, for example. People might name the specific data values, like show me the females. They would also use keywords that indicated filters like only or exclude or filter. And people also named a bunch of keywords that indicated operations or transformations we should do to the data. The second major thing that we learned from last year's study was the challenge of how people underspecify utterances or leave a lot of stuff out. When we talk to each other, we leave a lot of stuff out, as it turns out. And a computer then has the challenge of guessing at what was left out and using that to fill in the detail, all the details you need to make a viz, because computer can't leave things out when it makes a viz. It needs a complete, perfect specification. Let's look at an example. So one person in our study asked, were female passengers more likely to survive? Now, to me, and probably to you, this seems like a straightforward question. Probably most of us in this room could take the data set we had and produce some viz that would reasonably answer this question. But let's imagine that you couldn't speak English. So you didn't really understand the meaning of the words in this question. And all you knew were the set of words that were in the data set. And so what you were trying to do was pattern match between words in the question and words in the data set. And that's how you were trying to interpret what was said. That is kind of the task a computer system has to do. And that makes it really hard. So if we look at this sentence in this way, there are two words that match things directly in the data set. Female is a named value in the sex attribute, so it has male and female. So that suggests probably we want to filter to the females. And survive is pretty close to the attribute name survived, which was yes or no, which is also in the data set. So let's pretend to be a stupid, naive computer system. We'll take those two attributes, we'll hit show me, and we'll see what we get. This is what we get. It's a very, very unhelpful viz. So in order to be smarter and give a more reasonable response, we're going to need to infer a bunch of extra stuff to make this more useful. The first thing that we could do is infer a measure, because there was no measure specified in the question, but we could probably guess that the user probably, in most cases, wants to see a measure of something. And so a reasonable default here is to just add the number of records to the viz. So now at least I have some information from my data, not just the fact that it exists. But we can do better than that. Even more helpful than that would be to recognize that this question has an implied comparison. The user asked about females, but they also asked, were they more? And that suggests that they want to compare females to something else, and probably they want to compare females to males because that's the other aspect of that attribute. So if we infer that we should also include the males, and maybe even color code that difference so that it makes it really obvious, that would be far more useful. And if we wanted to do even better than that, we could realize that the word likely probably represents some sort of a percent calculation. People don't want to see the raw numbers. They want to see it somehow normalized by the number of males and females who were on the ship. And so if we turn that number of records into a percentage, we could be even more helpful here. So this is a much better answer to the question than the default one that Shomi would have given just taking the attribute names. All of these extra bits need to be inferred by the computer. They weren't directly in the question. And so Vidya is going to come up and talk about a bit later about what we're doing now in the product to infer these kinds of things, and on top of that, where we're going to be able to be even smarter in the future. OK, so to summarize what we learned from last year's TC study, first of all, we learned all of the ways that people express cues that indicate what they mean, what their intent is. And those we've taken and are building into the product in how we interpret language. And then we recognized just how underspecified these input questions are, and the need for inferring smart additions to make sensible visualizations, sensible answers that are meaningful and useful. And with that, I'm going to pass it over to Vidya, who's going to tell you about what we're doing in the product.
Thanks, Melanie. All right, so at the keynote, you probably saw kind of a sliver of what Ask Data could do. And I thought I'd take a moment to sort of highlight some of the key takeaways of the feature. As we know, Ask Data is a feature where users can ask their questions in natural language form. We call them utterances. And what is really important to highlight here is it's a feature that's built on Tableau's Analytical platform. And that's really important because on one side, we can take advantage of all the cool power that Tableau supports, whether it's level of detail or various analytical functions. But on the other end, kind of alluding to the notion of intent that Melanie talked about, there are certain constraints that we would have to satisfy as part of the feature so that the feature could use Tableau's platform. And I'll walk you through what that exactly means through some examples. And what is really important is natural language is a modality that can make analytics more accessible to people, but we're not really looking at replacing any of the existing modalities that already exist. Sure, we have drag and drop. It might be more convenient to ask a question in natural language form, but we also want users to hover over their visualization, look at the tooltips, click on marks, and so forth, being able to zoom in on a map, pan a map, so that they can gather insights in the data beyond just what natural language provides. So what are some analytical functions that AskData supports? We have 5 expressions, and I'll walk you through each one. The first one is an aggregation expression. So in this example, it's sum of price, where aggregations are functions where multiple individual rows are aggregated to form a single value. You could think of some examples as average, median, sum, count, count distinct. And group expressions, in this case it's by country, where a group expression would partition the data into categories that are shown in a data visualization. So by asking a natural language utterance, what's the sum of price for each country, the system translates that into a set of analytical expressions, in this case, sum of price by country, as a map, because country is a geofield. The third type of analytical expression is a filter expression. So here in France is a geospatial filter where the user would like to view wineries that are located in France, where we filter the set into a subset based on the field's domain. In addition to a geospatial filter such as in, we also support filter to, which is a categorical filter. So I could say filter customer name to John, or I could ask a numerical filter, so sum of sales that are at least $2,000 and so forth. The next type of expression is a limit expression, which is very similar to a filter expression. The only difference is a limit expression returns values up to n rows. So it could be top n or bottom n. And we display the results, and they're sorted in descending order for top and ascending order for bottom, so that relative comparisons are easier to make. So if you notice in Tableau, if you've used Tableau, the default bar chart comes unsorted. So AskData adds some additional embellishments to the visualizations to make them analytically more useful. And the last type of expression that we support is sort. So we support 3 types of sorts: alphabetical, ascending, and descending for numerical expressions. So with that, I will show a quick demo and kind of walk you through some of these expressions and highlight places where the system needs to infer underspecified utterances. And I'll walk you through some of the decisions that the system makes in terms of inferring the right one. Yes? So this is available for on-prem and online. And the feature will be released in 2019.1. And right now, we're running through a beta program, and we'll provide a sign-up link at the end of the talk. So if you're welcome to participate. OK, let's see. Hopefully, internet is functional. There we go. Zoom in a bit. OK, so Melanie and I are from California, the Bay Area. Even though Melanie is Canadian, she's pretty much now a Californian because she complains about cold weather. So that being said, wines is a topic of great interest to our team. So this is a wines data source published on server. And you can see that there are various dimensions and measures available in this data source. And if you actually hover, there is a useful tooltip which will basically give you some synonyms for the particular field. So for example, type is a synonym for variety. It also provides information on what are the most common values you could ask of the field and so forth. And in addition, what's the role? Is it a dimension? Is it a measure? Is it nominal, ordinal, and so forth? So kind of very similar to the data pane if you're familiar using Tableau. Out of curiosity, how many of you use Tableau? Cool, OK. So most of you. OK, so let me start. Let's start with time, because that's always a popular thing people ask. So I could say average price over time. And you notice here that I didn't specify the attribute alluding to time, but from what I specified over time, the intent behind this utterance is I would like to view this as a time series line chart. So the system takes the token time and figures out, okay, I need to generate a time series chart and I need a datetime attribute. What is a datetime attribute available in this data source? And in this case, it's vintage. And if there are multiple datetime attributes, the system will pick the most popular attribute. And popularity is based on a multitude of factors. It's based on how often people use that attribute in their utterances. It could also mean how often that attribute exists in worksheets that consume a data source and so forth. So I can click on this, and it'll generate a line chart. I can then continue and say 2015 wineries. So here, I'm interested in wineries, and I mentioned the year 2015. I, again, don't mention the datetime field. And it figures out the field. And notice here, it did not infer vintage's year, just the field, because based on Tableau's constraint, in order to do a filter, all it needs is a datetime field. It doesn't have to be aggregated to a particular datetime level. So I can click on that, and it'll show me all the wineries in 2015. I can then say top wineries. And in Tableau, if you've used a limit expression, one of the constraints that Tableau enforces is a limit expression needs to be aggregated by a measure. But it's very common for people just to ask top wineries without really thinking about, does this conform to Tableau's constraints? So we're making this easy for you, where the system will just infer a common measure, in this case, number of records, aggregates that to sum, so that I can see that this is the top winery and the number of records associated with that winery. I can also say sort wineries. And in this case, I haven't specified the sort type. And because wineries contains a bunch of text strings, it will infer a sort type, in this case, alphabetical order. But I could override that inference and say, actually, I want you to sort it by biggest. And I can click on descending, and it will show me a bar chart that is sorted in descending order. So another thing that Ask Data supports is during visual analysis, people tend to ask questions where they are really looking at, they really want a specific visualization type. So very similar to the first example that I showed, where I was asking for average price over time. So let me give you a flavor of those types of utterances. So I can say list of tasters. And here the system will fuzzy match tasters to taster name, even though I didn't spell out the field exactly how it's found. And I can look at all the list of taster names, and I notice that null is a top record here. And I can say exclude null. And I did not specify the field that I want to exclude null from, but because taster name is already in scope here, the system will infer taster name and exclude null from that visualization. I can also have fun with this and say country as a pie and get a pie chart. Some of my engineers were tempted to add a synonym for pie chart and have pizza in there, but I said, maybe not. So here, I asked for country as a pie chart, and because a pie chart also needs a measure in order to encode the data, sum of number of records is also inferred. I can then ask questions like correlate points with price. And in this case, correlation is best represented as a scatter plot. And the system will generate a scatter plot. And it's actually interesting here where some of the highest points also have a lower end of the price range. And there are a couple of outliers here. And my other example here is tasters and points as a tree map, because tree maps are very photogenic on a projector screen. So get a tree map. So we basically support, yes? Oh, sure, go ahead.
Is there going to be where you can have the measure be inferred from the most popular measure?
Yes. Yes, you can. So instead of sum of number of records, you could, I mean, the system could infer sum of points or sum of price. It's not, no, it's not something it's set. It's just based on popularity data. But you could also go into the refinement UI, and you can click on, say, a different measure and select that and override it. So the system will actually learn that behavior over time so that the defaults can get better. Yeah. So another thing that, that we can do is the Ask Data also supports various concepts. So for currency fields, there are a bunch of concepts built in. So I could ask for most expensive wineries. So it'll show me the top winery by most expensive price. But I could also ask some vague concepts. So I could say wineries with high points. And high is kind of a vague concept. What does high mean? So what the system does is it infers a sensible range. Right now, the default is one standard deviation from the mean. And as a user, I can go and change that range to something else and override that. And we're actively collecting telemetry information, so these sorts of overrides will be learned by the system over time. Yes, you had a question?
Yeah, three-part question.
Sure.
Is custom SQL supported with this? So it can run live against databases?
No, so we basically are, the feature is abstracted from whatever the underlying SQL language is that is used in Tableau. That being said, we do not have specific support for custom SQL queries, but that is something we're looking into in the near future. And part of that bucket list is custom SQL queries, custom calculations, just various custom functions that people would like to define and include with this feature.
So then will it also support parameters? So if I was to ask a question, the number of accounts that are associated with 05, maybe custom parameters.
Right, yeah, so the first version does not have support for parameters, but if there are parameters that are included in certain utterances, we do support them, but we don't have an option right now for users to be able to use those. And that also applies to groups as well, groups and sets.
My last part of the question.
Sure.
Because this is what I do when I publish online for our Tableau server within our organization. I'll publish the work, and I will that be available on Tableau server. Pull it up, type in a question.
Yes. So Ask Data is available on server, and it's available for published data sources. Yes. Any other questions before I continue with the presentation? Yes.
Will the record of all questions be maintained in the Tableau server? Because it'd be nice to be able to know all the questions that you're asking.
That's a good point. I just came from a customer meeting where the customer asks the same question. So we do have plans of storing patterns and the types of questions or concepts that people use in their utterances. For the first version, we don't have plans in terms of providing that usage data, say, to you. But we've gotten strong enough signals and requests from customers where we're looking into that and seeing if we can make that available, because I can see that being really useful. Yes?
For this to work, do you need to wrap up your data model in such a way it gives a more business-friendly name?
Yes.
Or it can go to the database?
Yes, so there is actually a white paper that explains sort of the best practices in terms of modeling the data. And if you meet me after the talk, we're happy to provide that link. But the short answer is, in order to use this, there needs to be some amount of data modeling to get the maximum benefit. For example, if you have 6 fields all named with sales, sales_1, sales_2, and so forth, the experience might be suboptimal because it's hard to know which of the sales fields the system needs to use, for example. Same thing with synonyms. We support users to add synonyms to fields, and adding synonyms can help make these utterances feel more natural.
So when you say users adding synonyms,
Yes.
so in a published data source, users can add synonyms which stays in the published data source?
Yes.
So it's kind of a write back?
It's a persistent storage of your synonyms associated with the published data source. Why don't I finish the rest of the presentation and we'll hold off. I love the enthusiasm, but I want to make sure that I get through the content before end of time. Okay, cool. And these will go by quickly because these are mostly a summary of what I showed, just to kind of impress on what the system can do. So so Ask Data can support underspecified utterances, so countries with rank 1, 3. A filter is not specified, but the system will infer a sensible filter, in this case between, and provide a response. Another example, which I stated, was top 10 countries, and the system will infer an aggregated measure and include that to satisfy Tableau's analytical constraints. And very similar with sort, where a ascending or descending sort needs to be accompanied with an aggregated measure, as seen here, as well as the product name or the dimension that is being sorted on has to be included in the expression. But the system will infer all this for you, so you don't have to really think about what you need to type. And time is really interesting. So take this example, sales throughout July 2016. And the intent here is, the user would definitely want to see a time series chart. And if we just infer the month, order dates month, you get a single dot, which is not very useful. So Ask Data will actually infer a aggregation at one level below what is in play in order to generate a time series chart. So for example, July 2016 is at the month level, and one level below month is week, and that is pulled out so that a time series chart can be generated. And just, over time, the default here is aggregating a date-time field by year. Location is another popular type of question that people can ask. So I could say life expectancy by location, or I can even say, where are my sales, or where are my customers, and then that data is represented on a map. Correlation is also supported. If you use Tableau, you're probably familiar with the single dot paradigm in the scatter plot. And what the system does here is it actually unaggregates these measures so that you can actually see the pattern without just getting a single dot, which is not analytically very useful. So with all of this intent logic, we don't anticipate that the system is always going to do the right thing. And with a lot of these features, especially natural language or machine learning and so forth, the feature only gets better when people start using it. So as part of that, Ask Data has this notion of refinement interaction. So it can be used to change a measure that has been inferred. It can be used to change a vague concept like expensive and tweak the range and save that. And over time, we're hoping that these algorithms can learn and get better so that smarter defaults can be provided back to the user for this data source. So it kind of walked you through what is currently in Ask Data and what the plans are. And I just wanted to spend some time telling you where we're going with this. So one part of this is being able to support analytical conversation. And what do I actually mean here? So let me explain with an example. So again, from California, so in addition to wines, the next topic of utmost importance is earthquakes, right? So if I'm looking at earthquake data, I can ask, find large earthquakes near California, and it'll show me these earthquakes set to a certain magnitude for this vague concept large. But we're looking at extending Ask Data to support context of the previous utterances that the user might have asked, so I could ask, how about near Texas, without explicitly saying large earthquakes, and the system will infer that from the context so that it feels more natural and fluid as you're conversing with your data. So in addition to looking at context just from the utterances and just a linguistic point of view, we're also looking at enabling context with the visualization in hand. So going back to the example that Melanie walked through, show me children aboard who survived in the Titanic passenger data, we'll give this bar chart, break this down by sex and age. As part of this analytical conversation flow, it's really important to keep the structure of the bar chart and add sex and age to the bar chart in a sensible way through visual encodings or nesting or breaking down the data in any way that makes sense. So those are some things that we're looking at. And in addition to kind of supporting building visualizations from the previous context, we also want to support almost a reset where a user may explicitly say, actually, I just want to look at the correlation between age, fare, and survival, and the system will need to make a smart choice of saying, okay, I can't show this intent in the current bar chart, so let me show a highlight table instead. So to summarize, Melanie and I talked about this notion of intent and how Ask Data tries to support users' analytical needs when they're asking questions in natural language form. And these utterances can often be underspecified or ambiguous, and it's very similar to web search. You might type in a question and it may not be fully specified, or it may not conform to Tableau's constraints. And I walked you through a few examples of how Ask Data will infer fields and attributes wherever it makes sense, and ways in which a user can override those defaults. And gave you a glimpse of some of the future directions where we're going, being able to support more concepts, dynamic calculated fields, for instance, and furthering kind of the flow of analytical conversation. And a bunch of you have asked, how do we participate? How do we try out Ask Data? And we have this QR code available if you want to take a snapshot with your phone, or you can meet us after the talk and we can provide you a URL where you can sign up. In addition to that, I'd like to highlight 2 lab activities that are happening at TC this year. One of them is around conversational analytics, and the other one is supporting calculations in this analytical flow. So if you have the time, we'd love for you to go visit Tableau Labs and participate and give us feedback to make this feature even better. And with that, Melanie and I are happy to take any questions. We do have a research website because a lot of this work started out in research. So if you're interested, there are papers related to this topic as well. So thank you.
Thank you. Saw a question down here in the front.
I'm interested in your kind of term of why utterances versus commands. Is it something that's related to you want something, or?
I like to think of it as it's not a command-based system where the user has to learn a command language. It's more a way that they can express themselves naturally. And so in human conversation, the word utterance relates to something a human says. And so that just seems to make sense here, too. It's also a terminology used in natural language literature.
Yes?
Yes.
No, it's only online and server. Online and server. Yes.
Their area sales manager, the suggestions that were on the right side of the screen will be tailored to that user, suggesting, yes, we think that you want to see sales in such an area,
That's something we haven't done yet, but something we have thought about, this idea of kind of tailoring the experience to, it could be any aspect of something that characterizes a user. You know, it could be their experience level, their domain, their preference for visual versus textual explanations of things. So yeah, I can totally imagine a future version that might do that, but it's not something we've had time to do yet.
Yes?
Are you able to share the visualization?
Yes. So there is a provision in the feature where you can save the visualizations. And once you save them, you can share those in the typical workflows that Tableau supports. But that being said, we're looking at other ways to sort of ease the friction of being able to kind of share stuff from Ask Data without having to save. But at least for the current version, you would have to save into a worksheet. Yes?
Two, if you don't mind. First one, to use the example that we saw in yesterday's keynote. Let's say we're searching for expensive or cheap, but then we put a qualifier before it. Not expensive, not cheap. What returns? Is it, if I say not expensive, do I get cheap?
Yeah. Right now, that's what you get.
Okay. And then what about in the case of like Instagram and bin? So does it assume just based off of like the data that it sees how to bin this by 10? Or can you change that? So if it's defaulted to bin by 10, can I say bin by 5 or something?
So right now, the Ask Data uses whatever default show me will generate as part of the viz. So coming back to the histogram, whatever show me sets as the default bin size is what you will get when you ask a question that generates a histogram. That being said, we're looking at ways to sort of fine-tune these vizzes, either bin size or you want to change the axis range. That sort of fine-tuning is not available right now. Yeah.
And I believe Show Me does something based on the underlying data distribution. So it's not going to just give you bins of 10 if your data is only from 0 to 1.
I'm just curious. I wanted to see if this version has histogram, because that was the most recent visualization we added. But you can take another question as I'm...
At the back. Not sure I can hear you.
Yeah.
Say it again.
To get a histogram.
Interesting. So that you would like to specify, you'd like to take the common phrases that were input and map those to what you actually think makes sense in the context of your data.
People don't say some, they don't know Tableau language, so they're not going to say some, or whatever.
Yeah, we hadn't thought of it in quite that way, but one thing we do want to enable is some customization of the language for each data source. And we do some of that now through aliases and synonyms, but a next step would be to take that one level further and allow you to do something like specify words and synonyms in maybe an ontology or something that would give you more of the domain-specific language that would be useful for your questions.
Is there a way of seeing the historical questions that you've asked or your historical visualizations?
No, the current feature does not provide a history. So one thing that we do want to do is when you start off with ask data for a data source, there are suggested questions. And we want to work on improving those suggestions so that they can stem from the common ones that people have asked of the data source before. But with a lot of these features, we suffer from a cold start problem, right? So, you know, when we give ask data right out of the box, there's no history, so we have to provide something. But over time, when we get more data, we're hoping that the feature can be tuned to your experience or the team that is consuming the data source. So that's part of the evolution as we collect more telemetry data. So please use the feature.
Is there currently the suggestions option?
Yes, there are suggestions. So, you know, like this particular data source, if I just, you know, start from the beginning. Sometimes Wi-Fi is a little slow here. Sometimes Wi-Fi is a little flaky, but yeah, suggestions will show up for the data source. I'm not sure why it's not working now, but yeah, and we're going to be collecting information so we can tune those. Yeah, so yeah.
Are there any other questions? Yeah.
Well, you had said earlier that it doesn't support custom SQL, but if it's a published SOAP data source, that's that underlying custom SQL.
Yeah, so that should work. That should work, yeah. We just don't support custom SQL that has to be dynamically created on the fly. It's only if it pre-exists in the data source, yeah. Well, thanks. Oh, yeah, one more?
One more.
Can you connect multiple data sources or?
No, it's only available for a single data source. You could have an extract that is pulled from multiple data sources and publish that.
Yeah, if you modeled that in Prep or Tableau and then published it as an extract, that would work fine.
Yeah. Yes, if you have calculated fields in the data source, they are supported. It really, I mean, they're not, there are certain constraints in how they are used in these analytical expressions, but yes.
Okay, thank you for coming. Vidya and I are still up here. We'll be happy to answer any more questions you have, but thank you.